All right. I think the levels are good. We're here. We're connected. All right. Welcome back. I am Agent Ultra, and I am here to hack on a little project I started a few weeks ago called Bakamud. It's a multi-user dungeon server, kind of like playing D&D online the old school way. Yeah, and we're building it in Haskell. Functional programming, kind of my thing. Kind of like it. Yeah, that's what we do on this stream. So, welcome. It's your first time tuning in. I am always open to questions, backseat programming, all those things, diversions, fun times. Without further ado, let's jump into the project. So last week, we were trying to get our stuff set up in order to do like logging and anything else we needed to add into our server. So we weren't doing everything in just like pure IO. Nothing wrong with that, but we anticipate the project getting a little bit bigger and expanding. And one of the libraries that I think I might use for this one, for the logging anyways, doesn't require it, but certainly makes it a lot more convenient if you do it that way. So we're going to try and go that route. I faffed around a little bit with this last week. We learned a few things, but I think this week we're going to have to nail it and try and move on. So, how are we going to do this? We're going to go with the ReaderT IO pattern for sure. So we need a new type. And where am I going to put that type? Server. Maybe it should be a top level one. Maybe it should be a top level one. Bakamud server. Now we're going to import a few things. Hold on, monad.reader. And probably a bunch of other stuff. The main focus is going to be our Bakamud type. Maybe we'll call it server. And let's go ahead and get this set up. Bakamud server. It's going to be a ReaderT of server state, which takes M, and that's going to be M and A. It's going to return. We derive our usual suspects, application applicative, functor, monad IO, monad reader, server state. We need to import that server state. Our child module. Well, this isn't going to be good. We're going to get cycles. Let's have to go get cycles. No, we'll be fine. We'll be fine. Yeah. Okay. So that's our ReaderT, and of course, whenever we have like a monad like this, we need a way to run it or execute its effects. So we're going to do that. We'll run Bakamud server. We're just going to have monad IO constraint on M, and we're going to say server state M and some Bakamud server MA, and we'll return MA. And that means we're going to take server state as an argument. First thing we're going to have to do is get Bakamud server, peel that layer off. Then we got to do something else. After that, we're going to run our ReaderT. Let's run ReaderT. Yeah, it's going to take our server state. I think that's it. To get our builder going. Oh, we don't have this in our Cabal file yet, of course, so it's not loading it there. So let's go and do that. Six modules. Okay, we're good. Sweet. Let's see. That's good there. So then once we have this, and what I struggled with last week was like where to run the Bakamud server. What is it? And I think all I did wrong was probably I should have just made it the top level thing. Run server, run TCP server. Should be such a Bakamud. And then we put our mod IO constraint on that. Like this. That's not in scope, so let's bring it in. No, it's not Bakamud. It's going to be Bakamud server. There. Okay. Here, we're doing all right. All we need to do now is run this thing. We have a place to do that. It's in our app. Main. All right, we got run TCP server, we got import Bakamud server. So instead of run TCP server, we're just going to run Bakamud server. And that means we have to give something for our server state. So let's make this a do. Right. We gotta give server state. And now we can give run TCP server here. We're just gonna need a couple of parameters, just as it did before. We'll change that up and refactor that out, but for now, that should be good enough. I'm gonna make GHC run command Cabal REPL exe Bakamud. There we go. Okay, so server state now, we got to construct that here. So we get that from server state. All right, yeah. All right, and we got to go, in order to construct one of these, we need an empty map of the connections and our log action. We have empty server state. I'm going to rename this to make server state. Okay. And that's all we need is that one parameter. HCID, do you need to be restarted? Oh, that's why. Some errors coming in. Okay. So now this is a Bakamud server. We can actually get the server state by asking for it. Yeah. That should be it. Ask isn't in scope. We need to import that. Control monad.reader. Var server state IO. Yeah. So our reader here wants it to be, we want it to be, this code wants it to be a TVAR. And we defined it as just server state. I think we can make that a TVAR. And then we need a control concurrent STM. It's STM, I think. We have to change that. This error. Oh, we have to give it a TVAR up here as well to construct. Okay, now we can ask for it, and we could match type M with IO. That's not right. It's gotta be this. Let's maybe port. Okay, let me just run GHCID normally then. Let's see if we can get this sorted. Let's see, could match type M with IO arising from the functional dependency between monad reader TVAR, server state IO, and instance of ask M1. Shouldn't need to.
If human beings are uploaded or augmented, I don't think it's appropriate to call them human anymore. They will be something else.
Might have to adjust these. there as well. Still think I can't ask on a monad ReaderT. Oh, perfect. Yep. Ugh, Emacs. Fix that. Okay. Server state. Main. Okay, what we end up is this. Yeah. Okay, so now should be able to build this. All build. Actually, we just run it. Let's just run it. Bakamud, that'll build it. Hey, Twitch D, what's going on? Welcome to the stream. Working on the mud. We are, yes. Just getting logging going, things set up. So we can expand further and add more, build on it. So we telnet to it, connected on our local host. 1000. Welcome to Bakamud. We got our logging, received connection. Now the difference is that our logging now is set up in main with our empty server state, and we pass that into our run Bakamud server with all this stuff. Ultimately, we put the server state network server here. Oh wait, I did this already. I forgot I did this already. Yeah, okay, so this one did it as a plain ReaderT. Okay, so I don't think I have that one. Let's get rid of that one. Now I was thinking of putting the server state in a T-bar so that if we wanted to pass around to the server state to different threads that are running different parts of the server, they could synchronize around that variable. But if we do it in a straight ReaderT here, the way it is, it isn't going to quite work. Unless we just make the ReaderT, or the state in the ReaderT purely like not mutable, or it holds T-vars. Might be able to do it that way. So first things, I think one thing I need to do here is just go back to main here and make those these parameters part of the configuration for initial state. I liked having this in its own module, but this is okay too, I guess. So the server state here, what I'm a little bit on is this map gets mutated when we add new connections, or it's supposed to be anyway. And if we have different threads doing stuff, mutating that map, we're going to have to put a T-bar around this. But first, we're going to add those parameters we need. It's server state host, and that's some type. Shut down that. It's going to be part of run TCP server, yeah. Service name. Oh, maybe host name. That's all right. Maybe host name. And server state port service name. Let's get our builder going. Try and do it from Cabal REPL from the XE so that we get everything. I think by itself, just GHCID just runs the modules in lib. Yeah, so those need to be imported. Network dot socket. Okay, that doesn't. There's something else I'm missing to the GHCID command because it's only loading main, and if I mess this up, it's not going to reload. You know what it is? It's a GHCID config file. It's no need. I forgot the identification for it. I think it's I source and app. GHCIE. GHCI, configuration. That's it. .ghcid, kill that file. It's .ghci. And we want subdirectories, yeah. App and source. We get it. Okay. And then we go here. So we're gonna need maybe host name and service name. Let's bring this over to the left a little bit. Okay. And then server. We don't need to create it here. No, we don't need a T-var around it anymore. We might need a T-var around it, but T-var around something. But all the places we've threaded server state through, I think we're going to have to remove that. In fact, we don't even really need to do that here anymore. We can just get rid of that. Oh, simulation. All right, this could be a Bakamud as well. Or something else, but we're going to make it a Bakamud. Bakamud server. And that comes from over here. And of course you don't have that. You need it from here. And that's probably circular import. Yeah. So I'm gonna have to move that up. Like I had it before. Will it do that? And we add that here. Key, I don't know why it's only loading 4 modules. That's kind of odd, but hopefully it's fine. Good all run. No. Yeah, the cycle is killing it still. Simulation. So this fork finally here is not going to work quite the same. So lift IO this. That. Going back to server. Okay. And then so forking off this simulation part of the code base. Fork finally is going to take an IO action there. We made it a Bakamud. So what I think we actually want here in our Bakamud is to have just the configuration stuff. This connection map, for example, I think is probably what we want to share here with the other thread, with the simulation thread. So let's go make that change as well. State. In fact, I think instead of that, there's a STM containers library that we're going to want to use. And so these are containers that act like map and set, as the documentation says. But they are transactional. So they run in STM transactions. And that way we don't have to like handle coordinating with the TVAR, right? We can unwrapping the TVAR, modifying the map, putting it back in the TVAR and all that stuff. We can do all those updates and stuff like that transactionally with STM. So I think that's probably where we're going to go with that. Do I want to do that right this second while I'm in the middle of this refactor? Not really. I kind of just want to get the ReaderT stuff going again and get us back to green before I go down that route. So, in order to do that, I'm just going to temporarily remove that. And we have to deal with these. Loop is applied to too few arguments. Right. We're going to run into our old friend bracket. That's fun. Let's try and solve loop though. Does need server state here. It's going to be a bad. IO and Bakamud server. Maybe we have to leave it that way. But we get this way. Okay. It's no longer a TVAR IO anymore. Just there. Yeah, and this line here is the interconnection's also going to be needing updating. So what are we going to do? We're going to initialize the connection. Turn the connection. We're just not going to do anything with it yet. We're getting back to our initial monad dependency issue, where something is demanding it to be IO, which is probably all these actions here. Right, because when we ask for a service state here, and then in these bracket functions, they're all IO, especially on loop here. Can I make loop more general? See if that helps here. Place all the places where we're kind of hard coding server state IO. Oh, still doing it. Hmm. don't think it's resolve or open, but let's see. Really having an effect. Let's ask part of this. Right, the M should be whatever environment we are in. We should be in Bakamud server. Let's try to match M with IO. And for some reason it's fixing server state as IO, but Bakamud server M. We don't fix it to IO here. Don't. Goes some R to MA. Takes a ReaderT RMA, some R, and then this A. So we give it the R first by flipping the argument, and this should be the ReaderT. It gets here. Turns that MA. So somehow ask is demanding, or ask for some reason is getting a constraint. But just the server state part of our monad reader is IO. The whole thing here. Terror. Might be a red herring. Something else is demanding an IO, non-empty address info. The whole thing. A bunch of these. Okay, let's try some of these. This one. Yeah, for some reason, I don't think this one needs to be. Yeah. Yeah, 56. That one. Bracket. It's going to force us to be that. Good times. Yeah, maybe I should just abandon this branch and try a different logging library that isn't going to force me to use ReaderT. The thing is, like, I should be able to use ReaderT over IO just fine with networking. That's the only thing that's getting me with this. Bracket is kind of fixed. It's not general enough. Is the only problem. So I should be able to lift IO that, because IO is at the bottom of Bakamud server. Should be able to run that, but loop has to be still IO. Here. Also has to be lifted, I think. No. No, that's too many layers. think it's just going to be an IO action. Same with connect. Then we're back down to at least these ones with init connection. We're going to start demanding IO again. And here as well. I wonder if we could just make it loosey-goosey. No, because then they're going to be two different monads. It's probably not going to work. TBQ, though. And a connection. Kind of goes, but then we got this problem with server 64 here. Because now we're no longer in Bakamud anymore. We're in IO. So our log action doesn't work. Because we can't get the haslog instance in order to get the log action. Arg. Arg. Okay. We need to do a little research. How can we use the bracket pattern or bracketing in ReaderT? TypeScript, no, sorry. Oh, I gotta run out. Finally, ReaderT. What's going on here? The simple case. All right, so let's forget any kind of grand solution. Instead, let's take one of the simplest monad transformers, ReaderT, and see if we can write a finally that works with it. Since a ReaderT simply passes in some environment to all actions, this turns out to be really easy. Now import finally, try an error call from control.exception. Create a finally ReaderT function. It goes from a ReaderTR IOA to ReaderTR IOB and a ReaderTR IOA. So we lift IO, we try running the A, capture it with finally, and then we run SQL. So the way you use this, you try to run ReaderT. Step 1, find the ReaderT. Step 2, with our environment. Oh, okay, okay. So then we can do our stuff in there. So step 1 will be a ReaderT, and step 2 will be a ReaderT. Yeah, we don't need to do state T so much. And this is getting a little bit more. Yeah, and I've been told we shouldn't really be using monad-based control these days, so that's kind of out of date. Yeah, okay. That kind of solves the problem here, because we're running cleanup actions in IO that we want to happen. We just happen to be running them in under ReaderT. So we could use our function instead of bracket. We can use a function like this. Finally, ReaderT. Is there something already like that, though? Okay, so we'll just borrow that. What Bakamud, monad slash reader. We need that's and Cabal. And we have that here. Finally, ReaderT. Okay, let's see if we can get this going. I'll pop that up here. Then we can go. Oh, it's not quite like bracket, is it? gonna be a little bit more complicated than finally. Okay, well, let's see if we can do a bracket then. Okay, so IOA, then ReaderT IOA. We have a function, a callback function. A to ReaderT IOB. A to ReaderT IOC. And we return the ReaderT and just IOC. ReaderT IO. So then A, callback B, callback C. CBCC. Okay, and then this will probably be bracket. We need R. This would be CB, and this one would be maybe CC. Oh, Well, that is kind of weird, yeah. So like A gets passed in here with callbacks, and doesn't use them really. And what would it mean to use it? Like the return value from this action in normal bracket right is passed into these actions. Well, it's IO, so it could do something with them. Right, okay, so that's fine. We just need to pass it into our callback there. Okay, and then we can go back to server. We have our bracket version of ReaderT. Yeah, relax. I open there, we can just go open there, close there, and loop server state. Okay, and now we're being a little too specific here about the ReaderT. Bakamud is a ReaderT, but it has a monad reader instance. It's like MR. That doesn't quite work. Mm-hmm. We get rid of that. Leave this at Bakamud. Server. No, thank you, three-way defense, whatever the heck that is. You're banned and reported. Okay. So then. Change that to Bakamud server. And close. I'll put that here. Guessing that's just the sock. Yeah, okay. It's still gonna be a thing. So we could specialize ours to Bakamud. Our bracket. Don't know if we can generalize it to any ReaderT with the monad reader constraint. Oh, it's RM. Okay, maybe it might be possible. maybe like this. Does that work? Okay, not quite. We don't have to make this super generic because we're only using this for Bakamud, so hopefully we won't have too many other monads we need. And we should be Bakamud server. Oh yeah, we don't need that. Just the Bakamud server. And it's not run ReaderT so much as run Bakamud server. Documents are all a little messed up. We're gonna flip these around. And then this is us wanting IO here. We did fix all of them to IO. Add. Okay, and then back to server. Boom. Okay, and then we don't need bracket ReaderT here now. We need bracket, unless we still call it bracket ReaderT. Call it bracket Bakamud. Sure. bracket Bakamud server. These, and do that. Nope. Initial action that returns that. It's open. Just put a hole there. Okay, I want something back on the server IO socket. What should be Bakamud's this? Should be that. Okay, yeah, so this is, we're expecting the types to be the same, but they're different. Enclose here. Right, 55. Oh, maybe, wait a second, I'm looking at the right line. That's 55, never mind. What's down here? Yeah. What type of that is? A unit. Okay, then this is just Bakamud IO again. Okay, so this one then. We lift IO this, will it work? No. Maybe we remove the... We kind of hard code it to IO here. Yeah, then once that hauled via socket to shaped like this. Right, socket to bucket Moses server IOA. Loop is, as long as you give it the server state, has that shape. So it's not, it should not loop. We're just stuck with this. Yeah, let's get rid of that up here too. Let's just fix all the M's to IO. Why not? Okay. Not super happy with that, but at least it compiles. Maybe it'll be fine. Let's clean up some of these warnings. And the simulation stuff we took out temporarily, but maybe we can put that. let's stage that here. A wrap on TCP server in a ReaderT. Bakamud server. Modify your TCP server. Don't need to get the simulation back in. Okay, we're running a little on time, but I think maybe we might not have enough time to do that. So, yeah, let's look at the server state. We're going to pull in STM containers for this. And STM containers. Let's try 1.2.1.1. While that's going, let's replace this map with that STM containers.map. Okay, so now that we've changed that, we can't use mempty anymore because it's not doesn't have a monoid instance for this data type, this data type. So here, I think we're gonna have to take it. We're basically some kind of IO action here. Because we still need to initialize it to an empty container. But if we make it a parameter, the caller has to initialize it to empty for us. But we don't know that it will be empty. Alright, so we should probably do that. And probably do it like yeah, all right, let's do it with a do block. Pow, pow. And import that qualified. And we'll get our new empty connection map. I think it was new IO or new, atomically new. Don't need atomically. Then control.concurrent.stm. There. Okay, our simulation code doesn't know about maps anymore, or STM maps, so it has to be updated. So we don't have a foldable instance for the container. Unfold him. That's gonna be fun. I don't think I've used unfold him before. It has monitoring. It has foldable, so we might be able to. Get the server connections. And then something, which will probably be the map. Thing. App, unfold in. Unfold LN, sorry. Okay, so then this doesn't become just a connection, it becomes a tuple, the connection ID and the connection. Okay, it cannot deduce foldable, even though we did the unfold M. Oh, only on identity. Okay, that's what it's saying. It doesn't have it on STM. Okay. Okay, so I need this package then, I guess. Deferred folds. I can filter on it. Whatever that is. Fold M. I don't know what a Gonzalez fold is. Okay, I think we're gonna have to. We're running out of time, so I'm gonna have to call it here. I have to learn a little bit about unfolds and Gonzalez folds in order to fold over this STM container. So we can comment this out for now. Let's see if we can fix this quickly. Server. We're gonna have to completely change all of this. Okay. Okay, we're gonna back out. And we'll just rip the simulation stuff out for now. Get rid of a net connection altogether. Actually, no, we can't. Okay, we're gonna move that for now. We'll have to add it back in. I'm gonna call it modify connection map. Replacing base map in normal containers map and server state with a STM containers map. Require a little rewriting. The connection code. Cool. So things are a little bit broken at the moment, but that's okay. We'll get it back. And start refactoring more to this architecture, and hopefully see how that turns out next week. So I usually do these streams once a week on Tuesday evenings at 10 after 8 in the Eastern Standard Time Zone. So if you want to write that down, that's great. Or if you follow me here on Twitch or on my YouTube channel where I back up these VODs, you give us a like, subscribe, leave me a comment, let me know how things are going. That'd be great. And you get notified when I post new videos or when I go online. You can get notified that way as well. So hopefully we'll see you next week. It's been a pleasure. Check out the link above my head. That goes to declarative.tv, a wonderful little website where you can find other streamers doing cool stuff in functional programming languages and declarative programming languages. Things like Elixir, various Beam languages, Haskell, logical programming languages, all kinds of stuff. So check it out. There's also a link to a Discord server for this stream on that website, so you can follow me there as well, hang out, ask your questions, chat about your own projects, and tell me where you're up to. Love to hear about them. And that's all I got for now. So may all your monads be free and your types always check, and we'll see you next week. Happy hacking out there.